Hello, Kaizen Sigma practitioners. The role of Kaizen Sigma green belts and black belts is to mentor problem-solving teams in the process of solving problem. And of course, they're going to need statistical tools and techniques. Then that is also your responsibility. So one of the techniques that you might want to share with your team is how to calculate the CPK when the sigma score of the process is given. I have here prepared a unique solution that might explain how this is uh, being calculated. Let us restate the problem as what is the CPK of a process that has a sigma score of 5. This problem seems to be difficult, unsolvable at first, but with some analysis, you will find that it is actually easy. So the solution would be, first you have to go to the Motorola's Six Sigma conversion table. So that is the basis of Six Sigma practice. So you will find in the column of Sigma score, score of 5, that the DPMO corresponding to this score will be 230 defects per million opportunities. But of course, I would like to give you a little background about what CPK and in particular what is CP. Okay. So to understand how this solution is going to come about. So CP, or the Process Capability Index, is the ratio of tolerance over Six Sigma. Okay? So tolerance is defined as the values that can be accepted by the customer. And you have the highest value that can be accepted and also the lowest value that is acceptable. We call them the USL, which stands for upper specification limit, and LSL, which stands for lower specification limit. Take note, for example, if thickness is the characteristic that we are interested to control, so there is a maximum thickness that the customer can accept, and that is USL. There is also a minimum thickness that the customer can accept. So in other words, in thickness, there is such a thing as too thin or too thick. So in between these two values are all the thicknesses that can be accepted by the customer. Outside of these values are defects, defective units, defective thickness. So you'll notice that in the middle, this is the bell-shaped curve of the normal probability, a normal curve of the data. So we are assuming that the data is normal or follows the normal probability distribution. So in the 3 sigma system, there is it is the all the values in between the process capability is equal to 6 standard deviations. In other words, the range of values that is generated by the system, highest value and the lowest value, has 6 standard deviations between them. Take note that the highest value of the process is different from USL, and the lowest value of the process is different from LSL, because USL and SLL are specifications. Whereas the low and high value of the process is a process performance. So in the middle, you'll find that this is the population mean or the X double bar. The population mean is being approximated by X double bar, which is the data, the average value of all the data that was taken. On how to get the X double bar is you get samples, say 10 units, and then take the average, and then get another 10 unit sample, and then take the average. And all these averages are going to be average as well. You're going to get the average of averages. So that is being represented by the X double bar. On the other hand, CPK is the process capability index closest to X double bar. Okay? So, I have here two illustrations about the two possible cases of CPK. This case at the left is the X double bar is closer to LSL. Therefore, this distance from X double bar to LSL is X double bar minus LSL. So that is the length of this distance. And obviously, this length is shorter than the USL to X double bar. So this distance is longer than this distance. So, according to definition, the CPK is the index that you use for the closer value of any specification to X double bar. So in this particular case, CPK will be having a formula X double bar minus LSL over 3 sigma. Why 3 sigma? Because you are only analyzing the half of the curve. On the other hand, you have the case in which the USL is closer to X double bar than the other half. Okay, so this distance is USL minus X double bar, and the formula for CPK in this particular case is USL minus X double bar divided by 3 sigma. Okay, so there is a third case, that is when CPK, when X double bar is midway between USL and LSL. When that happens, CPK is equal to CP, and you're going to use this formula. Because this one is midway, the X double bar is midway between LSL and USL. Now let's go back to the solution. It seems that this particular problem has only one way to solve it. And this solution doesn't require additional information. Otherwise, you will need some more information to solve a problem like this. This is the only solution, a unique solution that is possible to solving this kind of problem. So let us assume that the mean or the X double bar, okay, this is our mean, population mean, mu, is midway between USL and LSL. Therefore, we're following this illustration. CPK is equal to CP, or CP equals CPK. So the probability of defects would be 230 over 1 million. Remember, 230 defects per million opportunities. 230 over 1 million is 0.00023. Okay? This is the probability of this score to make a defect. So let us illustrate this problem. You have the USL here and the LSL at the other end. And the normal, the process performance is at the middle. This is the bell curve of the process performance. And of course, this bell has tail. No? This bell-shaped curve has tails. It is going to go straight to the left to infinity, and the other tail is going to, well, it's going to go to straight to the right in infinity, and the other one is going to go to the left towards negative infinity. And the probability that your data lies outside of the specification, no? Higher specification limit is going to be 0.000115. That is half of the probability of defects. Whereas the other half is going to be at this end. So this is also the probability of getting a thickness, for example, or data that is lower than the LSL is well, it is equal to 0.000115 as well. And if you look at the normal distribution table, you'll find that when the value of P, or the probability of the data, is 0.000115, the value of C is going to be negative 3.685. So, this value is going to be negative 3.685. Sorry. This is positive 3.685. This is negative 3.685. So let us negative 3.685. Okay? So the value of negative C and the positive C represents the LSL and the USL in this illustration. Now, let us use the formula, substitute these numbers. CP is equal to CPK. USL is 3.685 minus negative 3.685. Okay? Divided by 6 sigma. But sigma is going to be 1 when you have normalized the data. So, sigma is equal to 1. Therefore, this is 1. So 6 multiplied by 1 is 6. 3.685 minus 3.685 is 7.37. You're going to get 1.228. So 1.228 is the CPK of a process that has a score of 5. Thank you so much for listening. I hope that you learned something that you can share to your team.